Hi everyone, this is Miss Hsieh. This is the first part of a three-part series of mini lessons on stoichiometry. In this first part, we're going to talk about mole ratios and moles to moles stoichiometry calculations. Let's start by defining the term stoichiometry. So what is stoichiometry? Stoichiometry is used to calculate the amount of substances that go into and come out of any given reaction. So in a stoichiometry problem, you're given the amount of a substance in the reaction, and you are asked to calculate the amount of another substance in the reaction. You can think of it like this. I'm going to make a sandwich from 2 slices of bread, 3 pieces of lunch meat, and 1 slice of cheese. And I ask you, if I have 8 slices of bread, how many sandwiches can I make? Or, if I want to make 10 sandwiches, how many pieces of lunch meat do I need? Stoichiometry problems are a little like the questions that I just asked you about a sandwich. To solve a stoichiometry problem, we have to make use of something called a mole ratio. The mole ratio is given by the coefficients in a balanced chemical equation. Think of the balanced chemical equation as the recipe. So for example, here we have an equation for the synthesis of water. 2H2 plus O2 yields 2H2O. We can think of this as saying 2 molecules of hydrogen plus 1 molecule of oxygen makes 2 molecules of water, or we can think of it like this. 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. Just like in math, we write mole ratios as fractions, and the mole ratios show us the relationship between the given and the unknown in a problem. Here's the same balanced equation from the slide before, and we're going to write all of the mole ratios that we can get from this equation. So first, we have 2 moles of H2 for every 1 mole of O2. So we can write it as 2 moles H2 over 1 mole O2, or 1 mole O2 over 2 moles H2. We can also have a ratio between hydrogen and water. So 2 moles of H2 over 2 moles H2O, or 2 moles H2O over 2 moles H2. And finally, we can have mole ratios between O2 and H2O. So 1 mole O2 over 2 moles H2O, or 2 moles H2O over 1 mole O2. Let's do an example. Given the following balanced equation, Mg plus 2HCl yields MgCl2 plus H2, write the following mole ratios. A, Mg over H2. So what we would look at is the coefficient in the equation. The coefficient for Mg is 1, so it will be 1 mole Mg. And the coefficient for H2 is 1, so we will put that over 1 mole H2. B, HCl over Mg. The coefficient in front of HCl is 2, so 2 moles HCl over 1 mole Mg. And C, MgCl2 over HCl. The coefficient in front of MgCl2 is 1, so we would write 1 mole MgCl2, and the coefficient in front of HCl is 2, so 2 moles HCl. Now that we know what mole ratios are, we can start solving stoichiometry problems. There are 5 steps that I want you to follow. First, identify the given and the unknown. Next, write a balanced chemical equation. Third, convert the given to moles. If the given's already in moles, you can skip this step. Step 4, convert the moles of the given to the moles of the unknown, and you would use the mole ratio to do this. And finally, convert the moles of the unknown to the wanted unit, and we can skip this step if the wanted unit is moles. The simplest stoichiometry problems are moles to moles problems. This means that you are given the moles of a substance and you are asked to solve for the moles of another substance. Let's do a few of these problems to end this lesson. Given the following balanced equation, Zn plus 2HCl yields ZnCl2 plus H2, how many moles of hydrogen are produced if 3.0 moles of zinc reacted? The first step is to identify the given and the unknown. The given is 3.0 moles of zinc. And the unknown, which I'm going to underline in blue, is the moles of hydrogen. Notice that we are looking at 2 different substances. We are given zinc, and we are looking for hydrogen. The second step in the stoichiometry problem solving is to write a balanced chemical equation. Well, we already have a balanced equation that was given to us, so we can skip that step. Step 3 is to convert the given to moles. Well, our given is already in moles. It is 3 moles of zinc, so we can skip that step. Step 4, convert the moles of the given to the moles of the unknown using the mole ratio. So our moles of zinc, that's our given, 3.0 moles of zinc, and we are now going to use the mole ratio to convert to moles of hydrogen. Remember that the mole ratio comes from the balanced equation. So look at the balanced equation. We are interested in zinc and hydrogen. Everything else in that equation doesn't matter. So let's look at the coefficient in front of zinc. The coefficient in front of zinc is 1. That means 1 mole of zinc. We'll put that on the bottom because we want to cancel out moles of zinc. And now we look at the coefficient in front of H2. The coefficient in front of H2 is also 1. That means 1 mole of H2. We'll put that on the top. What this does is it allows us to cancel out moles of zinc. And now all I need to do is skip on to the next step. The next step says to convert the moles of the unknown to the wanted unit. Well, our wanted unit is moles, and we already have moles of H2, so we don't have to do that step. And this is the work completed. So really all we have here is 3.0 moles of zinc times 1 divided by 1, which gives us 3.0 moles of H2. Given the following balanced equation, C3H8 plus 5O2 yields 3CO2 plus 4H2O. How many moles of O2 are required to react with 1.50 moles of C3H8? The first step is to identify the given and the unknown. The given is 1.50 moles of C3H8, and the unknown is moles of O2. The second step is to write a balanced chemical equation. Well, in this case, the equation is already written and balanced for us, so we can skip this step. The next step is to convert the given to moles. Our given is already in moles, so I can skip this step also. The next step is to convert the moles of the given to moles of the unknown using the mole ratio. The moles of the given we have is 1.50 moles of C3H8. Now don't be lazy, you actually should write the formula for the chemical in the dimensional analysis grid. This is so that we can keep everything straight. Now we're going to look at the balanced equation for the mole ratio. 1 mole of C3H8, we will write that on the bottom. Now the reason why we would write this on the bottom is so that we can cancel out moles of C3H8. And the coefficient for O2 is 5, so we'll write 5 moles of O2 on the top. The last step is to convert the moles of the unknown to the wanted unit. Well, our wanted unit is moles, so we don't need to do anything here. We can just skip this last step. So this is the work completed, and in the calculator we will put 1.50 times 5, and the answer is 7.50. I'm keeping 3 sig figs because my given has 3 sig figs. And don't forget our unit. The unit is moles of O2. How many moles of water will be produced when 0.255 moles of CO2 are produced from the reaction? Again, the first step is to identify the given and the unknown. The given is 0.255 moles of CO2, and the unknown is moles of water. Just like in part A, we already have a balanced chemical equation written for us, so we don't have to do step 2. Step 3 is to convert the given to moles, and again, we already have moles, so we can skip the third step. The fourth step is to convert the moles of the given to moles of the answer using the mole ratio. So the moles of the given is 0.255 moles of CO2. And now we're going to look at the coefficient in the balanced equation. The coefficient for CO2 is 3. So we'll write 3 moles of CO2 in the bottom. Again, we would write it on the bottom because we want to cancel moles of CO2. The coefficient in front of water, H2O, is 4. So 4 moles of H2O will be written on the top. And the fifth step is to convert the moles of the unknown into the desired unit. Well, our desired unit again is moles, and we already have moles of H2O, so we can skip the last step. The work is complete, and all we need to do is put this in the calculator. 0.255 times 4 divided by 3. And the answer needs to be rounded to 3 sig figs, and that would be 0.340 moles of H2O. So this is our first mini lesson on stoichiometry. Stay tuned for part 2.